If you want to, like, totally break an astrophysicist's brain right now, just show them a picture of a galaxy that shouldn't exist.
Oh, absolutely. Just, hand them visual proof of something so massive and ancient that it just shatters the models of how our universe was built.
Right. And lately, the James Webb Space Telescope has been sending back dozens of those exact pictures. We're looking at cosmic structures that are effectively tearing up the textbook on early cosmology.
It really is. It's wild to see the data coming in.
It's incredible. So, welcome to today's deep dive. We are jumping straight into a piece of source material titled Webb's Vision, Rewriting the History of the Universe.
A very bold title.
Very bold. And the focus of our exploration for you today revolves around one highly specific, highly provocative claim from this text, which is how this particular telescope is rewriting the history of the universe through new images. Okay, let's unpack this.
I'm ready.
Because the mission for our deep dive is to understand the actual mechanics of how a piece of orbiting technology is actively dismantling our established cosmic timeline. We're moving past the philosophical awe of space and digging into the friction between the standard cosmological model and the physical reality Webb is beaming back to Earth.
Yeah, and the phrasing of the source text, specifically that term Webb's vision, that's really our starting point.
Right, because it gives the telescope, like, human qualities almost.
Exactly. When the text attributes vision to a telescope, it's referencing a very specific expansion of human capability. I mean, human vision is biologically limited to a tiny sliver of the electromagnetic spectrum.
Just visible light.
Right, we just see visible light. And for decades, our greatest astronomical instruments, like the Hubble Space Telescope, they primarily operated within that same visible spectrum.
Peering into the dark and just, mapping out the cosmos based on the light our eyes evolved to understand.
Which means our entire historical model of the universe was constructed using a heavily filtered lens.
Wow. Yeah, I guess that's true.
We built the timeline of the cosmos based only on what shone brightly enough in visible light to reach our orbital cameras. But Webb doesn't care about visible light.
No, it doesn't.
Webb's vision operates almost entirely in the infrared. What's fascinating here is the physical necessity of that infrared vision.
Tell me more about that, because infrared sounds cool, but why is it necessary?
Well, to understand why Webb is rewriting history, you have to understand the mechanics of cosmic expansion. The universe is not static.
Right, it's been expanding since the Big Bang.
Exactly. And as the fabric of space stretches, the light traveling through that space stretches with it.
Oh, I see. So it's like the Doppler effect, right?
Yeah.
But for light instead of sound.
Yes, perfect analogy.
Like when an ambulance drives away from you, the sound waves stretch out and the pitch of the siren drops. So in space, as early galaxies accelerate away from us due to the expansion of the universe, their light waves are physically stretched.
The wavelength becomes longer. So a galaxy that emitted brilliant, blinding ultraviolet and visible light, say, 13 billion years ago?
Yeah.
Well, it's had that light stretched as it traveled across the expanding universe. By the time that light reaches Earth today, it's been stretched so far that it drops completely off the visible spectrum.
It shifts into the infrared.
Precisely. Astronomers call this cosmological redshift.
Okay, so when Hubble looked at the deepest, oldest patches of the universe, it saw nothing. Not because there was nothing there, but because Hubble was effectively wearing the wrong glasses.
That is exactly it. The light from those ancient galaxies had stretched past Hubble's visible light detection capabilities. It was just invisible to it.
Wow. And Webb was engineered specifically to catch that invisible light?
Right. It is equipped with sensors cooled to near absolute zero, and it's parked 1 million miles away from Earth at the L2 Lagrange point.
Which is super far.
It is. And it has to be, just so the ambient heat of our own planet and sun doesn't blind its delicate infrared detectors. So Webb's vision is really the ability to perceive the redshifted ghosts of the early universe.
I love that phrasing, redshifted ghosts. And I think this brings up the most crucial concept for anyone trying to wrap their head around this source material. Because of the speed of light, Webb's infrared vision is a literal time machine.
It really is. I mean, light is fast. Roughly 186,000 miles per second.
Super fast.
But the universe is incomprehensibly vast. When you look at the moon in the night sky, you aren't seeing the moon as it is right now.
You're seeing it as it was 1.3 seconds ago.
Exactly, because that's how long the light took to cross the distance to your eyes.
And when you scale that mechanic up to cosmic distances, the implications become staggering.
Yeah, when Webb captures an image of a galaxy billions of light years away, it is catching light that left that galaxy billions of years ago.
Imagine spending your whole life in a dimly lit room, right? Thinking you know exactly where the furniture is. Webb's vision is like suddenly turning on a floodlight. The room hasn't changed, but your reality of it completely shifts.
That's a great way to picture it.
Or, imagine receiving a postcard from a friend who moved across the world, but the mail system is incredibly slow.
Cosmic mail system slow.
Yeah. By the time the postcard arrives showing a picture of their brand new puppy, 10 years have passed. You are looking at a 10-year-old snapshot.
Right, that puppy is now a senior dog, but your only visual data is from a decade ago.
Exactly. Webb is catching postcards of light that were put in the cosmic mail system 13.5 billion years ago.
Which means Webb is showing us the universe exactly as it looked just a few 100 million years after the Big Bang.
Which is just wild to think about.
It is. And this is the mechanism the source text is referring to. The vision isn't just about seeing farther away.
Right.
It is about seeing further back in time with unprecedented clarity.
Okay, here's where it gets really interesting, and I want to push back on the premise of the source text for a moment.
Sure, go for it.
Let me play devil's advocate for you listening right now. We have had history rewriting astronomical images before.
We definitely have.
Like the Hubble Deep Field image in the mid-90s, that revealed thousands of galaxies in a patch of sky we thought was totally empty. That was a huge deal.
It was a monumental shift.
So why is the source text treating Webb's new images as this unprecedented, paradigm-destroying event? I mean, how can a simple image rewrite history? We take images on our phones every day and they don't rewrite the history books. Are we putting too much weight on these new images the source mentions?
It's a fair question.
Yeah.
But the pushback is essential because it highlights the difference between discovering new details and discovering contradictory data.
Contradictory data.
Right. Hubble showed us that the universe was more crowded than we thought. Webb is showing us that the universe is behaving in a way that our current models of physics say is impossible.
Wait, impossible?
Yes. To understand why, we have to look at the lambda CDM model.
Ah, the standard model of cosmology.
Exactly. Lambda cold dark matter. This is the reigning framework for how the universe evolved.
Okay.
According to lambda CDM, after the Big Bang, the universe was a hot, soup-like expanse of elementary particles. As it cooled, dark matter, the invisible scaffolding of the universe, began to clump together through gravity.
And normal matter, like hydrogen and helium gas, was pulled into these dark matter halos, right?
Right. And eventually, this gas became dense enough to ignite the very first massive, short-lived stars.
And the model says this was a slow, hierarchical, bottom-up process. Those first stars grouped into tiny dwarf galaxies.
Yes, very tiny, very chaotic.
And over billions of years, those tiny dwarf galaxies smashed into each other, merging and slowly building up into the massive, mature, complex galaxies we see today, like our own Milky Way.
That is the established history of the universe. It requires time.
Yeah.
Billions of years of cosmic construction. But Webb's new images are capturing galaxies that existed roughly 300 to 500 million years after the Big Bang.
Which doesn't sound like a lot of time.
In the grand timeline of a 13.8 billion-year-old universe, 500 million years is the blink of an eye. It's the absolute dawn of time.
Wow.
According to lambda CDM, at that point in history, we should only see scattered, chaotic baby galaxies just beginning to form.
But that's not what Webb's postcards are showing us, is it?
No, it's not. The images reveal galaxies that are monstrously huge. Galaxies with the mass of the Milky Way, fully formed, packed with mature red stars sitting right there at the beginning of time.
That is just, to borrow an analogy from archaeology for you listening, it's like digging down into a Paleolithic site, expecting to find stone tools and campfire remnants, and instead unearthing a fully constructed, modern steel skyscraper.
That is a perfect way to describe it. The object itself contradicts the timeline of the strata it is buried in. The visual data cannot be reconciled with the established history.
Okay, but as an observer trying to make sense of this, my immediate question is, could the telescope just be wrong?
A lot of people ask that.
Because space is full of dust, right? Cosmic dust absorbs blue light and scatters it, letting red light pass through. This is why sunsets on Earth look red. The atmosphere scatters the blue light.
Exactly.
Could interstellar dust simply be making these galaxies look redder and therefore further away and older than they actually are? Couldn't this just be a massive calibration error?
You know, that was the immediate assumption of the scientific community when the first images dropped. Astronomers are naturally skeptical.
As they should be.
They assumed the initial distance measurements, which were derived from something called photometric redshift, which is a bit of an estimation, they assumed those were flawed by dust interference.
Right, just a trick of the light.
But then they brought in Webb spectrographs.
Ah, spectroscopy. Breaking the light apart to see its chemical fingerprint.
Exactly. Spectroscopy does not guess. It takes the light from the galaxy and separates it into its component wavelengths.
Mm.
It looks for the specific, undeniable absorption lines of elements like hydrogen and oxygen.
Oh, wow.
And because we know exactly where those lines should be in a laboratory on Earth, we can measure exactly how far they have been shifted into the infrared by the expansion of space.
So the spectroscopic data confirmed the distances?
It did. The distances are real. The galaxies are actually that far away, and therefore they are actually that old. The skyscraper in the Paleolithic dirt is real.
That is unbelievable.
The new images are not just pretty pictures. They are hard, verified data points that fundamentally break the lambda CDM timeline of galaxy formation.
And I think that's why the source text uses the phrase, through new images, because the visual proof is the mechanism forcing the scientific community to abandon its previous certainty. You can debate a theoretical model, but you must reconcile with the physical evidence.
Exactly. Another thing about these new images is Webb's ability to pierce through the cosmic dust we were just talking about.
Oh, right.
Visible light bounces off dense clouds of gas and dust, but infrared light glides right through it.
Like the famous Hubble image of the pillars of creation.
Yes, those towering, opaque columns of cold gas where stars are born. Hubble showed us the outside of the clouds.
But Webb took an image of the exact same pillars in infrared, and suddenly the dust became translucent. We could see the thousands of stars incubating inside.
Right, and that structural penetration applies to the early universe as well. The era Webb is looking at is often referred to as the cosmic dark ages.
Because it was just dark.
It was a time when the universe was filled with a thick fog of neutral hydrogen that absorbed visible light. Webb is looking right through that primordial fog.
The history books said the fog took nearly 1 billion years to clear, didn't they?
They did. But Webb's images suggest the fog was burned away much earlier by the intense radiation of these massive early galaxies.
Okay, so what does this all mean? I mean, we've established the mechanism of how Webb sees in infrared, how that equates to looking back in time, and how the massive galaxies it's spotting contradict the standard models.
Right.
The source material claims this is rewriting the history of the universe. Just think about how wild it is that the history of the entire universe is effectively treated as a rough draft.
If we connect this to the bigger picture, the required rewrite is profound. I mean, human history is usually rewritten by newly discovered documents or shifting cultural perspectives. But here, cosmic history is being rewritten.
The baseline understanding of how everything came to be.
Exactly. If the lambda CDM model is wrong about how quickly galaxies can form, then astrophysicists have to alter the fundamental laws governing the early cosmos.
So what are the options on the table? I mean, if the skyscraper is there, how did it get built so fast?
Well, there are a few theoretical pathways being debated right now.
Okay.
One possibility is that star formation in the early universe was wildly more efficient than it is today.
How so?
In our local universe, a cloud of gas might turn maybe 10% of its mass into stars. Perhaps in the extreme density of the early universe, that efficiency was closer to 80 or 90%.
Oh, wow. So the gas clouds were just hyper-productive star factories.
Exactly.
Meaning the galaxies didn't need billions of years to accumulate mass. They just burned incredibly bright and fast right out of the gate.
That's one option. Another option is that our understanding of dark matter is flawed.
Oh, boy.
Yeah. The entire bottom-up assembly model relies on cold, dark matter moving sluggishly, slowly clumping together.
Right, the invisible scaffolding.
But if dark matter behaves differently, perhaps interacting with itself in ways we haven't predicted, it could have created massive gravitational wells much earlier.
Pulling in the normal matter at accelerated rates.
Exactly.
Or I suppose we have to rethink gravity entirely.
That's the third option. There are modified theories of gravity that don't rely on dark matter at all, which might explain how mass accumulates without the scaffolding.
Regardless of which theory wins out, the baseline reality is that the textbook is currently being shredded.
It really is. And the phrasing of the source text rewriting, it's an active, continuous verb.
It's not just a one-time event.
No, it is not a historical event that happened when Webb launched. It is happening every single time the Deep Space Network downloads a new batch of data from the L2 point.
Every spectroscopic confirmation of an impossibly old, massive galaxy forces another revision to the timeline.
It demands a massive amount of intellectual humility.
It really does. We often look back at ancient civilizations who firmly believed the Earth was the center of the universe, and we view them through this lens of modern superiority.
We assume we have it all figured out now.
Right. But this source text is a stark reminder for all of us that our current history of the universe, the one taught in university physics classes right this second, is just a provisional placeholder waiting for a better telescope.
It is the scientific method operating at its most extreme scale.
Absolutely.
We built a theoretical framework based on the limited data our tools could gather. We designed a new tool explicitly to test the edges of that framework.
And the tool worked.
The tool worked, the framework broke, and now we must build a new one. The history of the universe is not a locked vault of facts. It is a living document.
And the James Webb Space Telescope is the pen. By capturing infrared light that has been traveling since the dawn of time, it provides the indisputable visual evidence that forces the rewrite.
The new images are portals to a reality we didn't have the biological or technological capacity to perceive until now.
We're witnessing the transition from a history heavily reliant on assumption and extrapolation to a history grounded in direct observation.
The dark room of the early universe is finally being illuminated.
Well said. Let's bring this deep dive to a close and summarize the incredible ground we've covered today. We started with a staggering claim from our source material that a piece of technology is actively rewriting the history of the universe through new images.
And we examined the mechanics behind Webb's vision, how the expansion of the universe stretches ancient light into the infrared.
Right, the Doppler effect for light.
Yes. And how Webb's specialized sensors catch that redshifted light, functioning as a literal time machine.
We analyzed the new images not just as photographs, but as hard spectroscopic data points. And we explored the massive friction between the established lambda CDM model of slow galaxy formation and the reality of the universe-breaking, fully mature galaxies Webb is finding at the dawn of time.
The skyscraper in the Paleolithic dirt.
Exactly. It's just so exciting to be alive during a time when the universe's history is still being drafted.
It truly is. And the source tells us that Webb's new images are rewriting the history of the universe right now. This raises an important question for you to consider long after this deep dive ends.
Oh, I like this. What is it?
If our foundational understanding of the universe's history can be completely rewritten just by getting a better look, how much of what we consider to be absolute, undeniable truth in our daily lives is just waiting for a new lens to prove it wrong?
That is a brilliant thought to leave on. Keep the lights on, everyone. We'll see you next time.